Hi, welcome to ARISTOTHINK. Today we're going to see a friction problem about physics. The problem is extensive, so I'm going to have to cut this video in some parts so it doesn't get very big. The problem goes like this. There are three blocks. Blocks 1, 2 and 3. Blocks 1 and 2 are not moving at first. They are at rest and there is no friction beneath those blocks and the surface. They are both 50 centimeters wide. This is centimeters, okay? That is block 3. And this one I'm going to put already with 3 meters per second. I'm going to throw this on top of block 1, like this. And it's going to slide. It has an initial speed of 3 meters per second. The friction between those two, there is friction, of course, is 0.6. Of course there is friction, because if there isn't friction between those two, as soon as I put block 3 is going to slide like a butter, and is not going to do any change into block 1 and block 2 speed. Right? So we gotta have some friction here. So as we have some friction, as I throw block 3 on top of block 1 and 2, what's going to happen? This friction force, if there is no friction, look, goes like butter, nothing happens. Just like water, if you just go on top of water like skiing or like on the snow, you just go, nothing happens. But if there is friction, so what's going to happen? Well, as soon as block 3 lands on block 1, is going to carry on block 1 forwards. But we have to understand that this block is going to slide, maybe is going to leave block 1 and even go to block 2 if friction is not enough to hold it on top of block 1, and the story goes on. So like I told you, it's not a short video, but you're going to learn a lot if you're interested on this problem. If it holds in your interest, I promise you're going to learn. Now I want you to plot to me the speed chart. Speeds against time for block 1, for block 2. I don't know which one is going to be what, but there are going to be 3 curves. I want you to plot me all of them until everything stops. I mean, until block 3 stops. Now, or up to infinite, whatever. It's not going to change this statement on this problem. The first thing I want you to do is this. I want you to be able to draw the free body diagram. Why drawing the free body diagram? We have to start drawing the free body diagram to understand what's going to happen. Our first question is this. Is block 3 going to stop on block 1 or on block 2? For that, let's take this question first. So the first point is going to be, we have block 2, 200 grams, this is grams. We have friction force, this direction. So F equals ma. I'm probably going to have like 3 or even 4 blackboards, I don't know. So you're going to have patience. I'm going to raise the blackboard and start over again. So force ma. So the friction force is going to be what? Is going to be mu times the normal force equals m times a. So mu is 0.6. The normal force is going to be mass times g equals ma. Oh, one thing. The friction force, I'm going to adopt this being positive. So the friction force is going to be minus. Why? Because everything in this direction is a plus, everything in this direction is a minus. So put this minus here, it is important. Mass cancels out, so acceleration is going to be, let's put g equals 10. So acceleration of block 3 is going to be minus 6 meters per second squared. This part is done. Now, next part. Well, I want to know if block 3 is going to stop on block 1 or on block 2. I know it's going to slide. For how long? For the distance. So the second point we have to ask ourselves is this: where is it going to slide? I know it has an initial speed of 3. I know it has negative acceleration. What are the formulas? Let's review the formulas. We have like s equals s0 plus v0t plus at squared over 2. The second equation is v equals v0 plus at. The third one is the Torricelli one. V squared equals v0 squared plus 2ad. We have those 3 equations. Which one are we going to solve? I want to know the distance. I have acceleration, I have initial, so, but I don't have time. And I'm not worried about time right now. So, I do have the final speed, don't I? Yes, I do. Why? Because final speed is 0. If I want to know when it's going to stop, this is 0, this is 3 squared, acceleration, and I can tell how long it's going to be. So let's use Torricelli. So we're going to use this equation. So final speed is going to be 0, because it's going to stop. Eventually I know when is it going to stop. It starts with 3 plus 2 times acceleration times the distance. So what's going to be? Well, I'm going to throw this side, that side, so the distance is going to be what? 9 over 12, which is the same as 3/4, which is 0.75 meters. That is very important, because now I know that block 3 is going to stop in the middle of block 2. So I already know what's going to happen. Now the second part I need to know is this: for how long is it going to last this path over block 1? Now I have to do this. Now I need to know the time. So I can use what? This equation? But I don't know final speed. No, I have to use this equation here. So s equals s0, it is the same as delta s equals v0t plus at squared over 2. Got it? I'm going to use this equation. Now, what is delta s? It is the 50 centimeters, isn't it? So I have to use this. So it's going to be 0.5. It is the distance. I want to know the time. It's going to be on top of block 1. It's going to be initial speed, 3 times t. A is minus 6, so minus 6 divided by 2 minus 3 minus 3t squared. So what's this? Now we have a second degree equation. So t is going to be what? I'm going to multiply everything by 2. I don't want to work with decimals. So 1 equals 6t minus 6t squared. So I have 6t squared minus 6t plus 1 equals 0. Now, the time, we're going to have t1 and t2. One time is about 0.75. Let me see on my notes here. Time. Yeah. One is about 0.75. I'm not certain. We're not going to use this one. About. The other one is 0.21. 0.21 seconds. Now you have to face yourself. Which time am I going to use? Sometimes the time is negative and you just throw away the negative number. Big deal. Now both are positive. So this is the first problem students face. What's going to happen here? Why 2 times? Well, why 2? Because you see, this equation, any one of those equations, they have no idea. They don't care about friction. They don't. For them, we have a block with 3 meters per second. We have acceleration of minus 6. So it's going to be a retarded movement. And as far as these questions is telling is this: I have a block going 3 meters per second with a negative acceleration of -6. So this block is going to reduce its speed like this. This is speed, this is time. Is going to reduce its speed from 3 up to 0, and then is going to start increasing again. It's going to continue. It's going to start increasing again negatively the speed until infinite. You see? So 3 up to 0, then -1, -2, -3, -4. This line is the same. Why is it the same? Because the acceleration, delta v, delta t, what is the alpha? The tangent of alpha is going to be what? Delta v, delta t. This is the acceleration, isn't it? So we have seen that if acceleration is the same, negative, that's why the tangent is negative, you see? It is negative. This acceleration, it is -6. Negative because if it was positive, the line would be in this direction. So a single straight line and accelerating, and now this is retarded movement. This is accelerated movement. So you see how many things we have to remember. Now, what's going to happen here? Well, as far as those equations are concerned, the block is going in this direction, stop, and then come back again. Accelerating now, because now speed and acceleration are on the same direction. So accelerating, braking. Now, that's why we have two numbers here. The first number, the first time is going to pass through position 50 centimeters. Then it's going to stop in here, which we saw of 75 centimeters. So this block is going to move all the way in here, then it's going to start coming back. This is the second time it's going to pass through this point. So the first time is at 0.21 seconds. It's going to stop and it's going to return. The second time it returns, speeding up negatively, is going to be times 0.75. And you say, of course, it's not going to happen this. I know it's not going to happen. But that is why we have those two. So we are going to ignore that. So we're going to use only this sign. So now we have this sign. Time is 0.21 seconds. Okay. Now, let's stop in here. This is going to be the first part of the video. On the second part, I'm going to solve what's going to happen on block 1 and then on block 2. So, see you next time. Bye-bye.